Okay, today is 3.1, and this is a new chapter, and it's all about functions, and especially functions that get either added to other functions, or subtracted from functions, or multiplying two functions together, or dividing two functions. And then eventually, when we get later in this chapter, we'll be talking about composition of functions, where you put one function into another function, like f of g of x. And the thing that's really easy about this is if I just want to add them together, just add them. You take that plus that. So if I wanted f of x plus g of x, I just put an empty parenthesis and drop in f of x, plus an empty parenthesis and drop in g of x. Now I know some of you are saying, why do you need those parentheses? You're just going to drop them anyways. Sometimes you do, but sometimes you don't. You need those parentheses because sometimes when you're subtracting, it matters. Do you get if I change this to a minus? Now all of a sudden the parentheses actually make a difference? And that's the number one thing kids do wrong on this. So I'm trying to prevent you from making a really common mistake. They forget to distribute their negatives out properly. And a lot of this is just simple algebra. Today's lesson is not super intense math-wise, other than you got to be able to be careful with your distributing of negatives. All right. So what's f of x times g of x? Well, times. There's my two functions. F of x is this, g of x is that. Now I multiply them. It just follows the normal rules, just that times that and that times that. You distribute it out. So that's all really easy. So why is this even pre-calc? Because you did this kind of stuff in higher algebra. Because now we talk about the domains of each of them. All right, new slide. Everybody add a page or get some room where you can write, because this example is a good one and it's not on the smartboard. F of x is going to be 2x plus 3, where x is greater than 1. G of x, I want to make a little more room for this. G of x is equal to, let me think, square root of x plus 3. Now let's think domains of these functions. That's what I just said a second ago was going to be the complicated part. Do you get that this right here, that's a domain? That is the domain for the f function. It tells you right in it. That's called a artificial domain. An implied domain is one that it didn't say it, but I know that this needs to be bigger than or equal to 0. That's an implied domain. This one's just right out there saying it. Hey, by the way, idiot, it can't be big. It has to be bigger than 1. Here, you have to kind of imply that, oh, of course you would know that x plus 3 has got to be greater than or equal to 0. Then you solve it, subtract 3x is greater than or equal to negative 3. So this is the domain of G. We call it D sub G. This is the domain of F. It was given to us. It just said it. X is bigger than 1. All right, so we got the domain of the one, we got the domain of the other. Remember what that really means. That means that if you try to stick in any other numbers than that, the functions won't work right. Now you might say, but Mr. Server, you could put in 0 into this function, and yet our domain says it has to be positive numbers. Well, you're right. That's why we call it an artificial domain. It doesn't make sense in looking at the function, but you can just trust that if we tell you it has to be bigger than 1, there's a reason. Like, for instance, would you have a reason to make a function that would ever involve temperatures on our planet that are like below 200 degrees? No, because it doesn't ever get that cold on this planet. Okay? I'm talking about degrees Fahrenheit. And I know, if I wanted to, I know there's always people that are looking for the exceptions, and you guys are smart kids, so you're probably thinking, is there a possibility there ever could be? There are incredibly hot temperatures on this planet. There's temperatures of positive thousands of degrees, but I don't think it ever gets lower than, like, I don't know, negative 100 or negative 150 or something, doesn't it? I think that I'm safe to say it doesn't get lower than 200. But anyway, the point is that we can artificially restrict the domain and just say, hey, I know from what I know about this problem that I want you to say that I don't want any numbers unless they're bigger than 1. That's an artificial domain. And it's just, you got to take whatever they say, and it's actually really nice because if they tell you the domain, you don't have to figure it out. On this kind, you have to figure out the domain and then come up with the answer. All right. Now, I like to think of domains as they are what works in the function, okay? And so that's like positive traits. Your parents, when we're making a combined function, like f of x plus g of x, that is like two parent functions together creating a new function. That's like two parents creating a child. So your parents pass down things to you, okay? I've got a friend, for instance, who's got the hook pinkies. You get the hook pinky? All right. If you have the hook pinkies, your pinkies don't go straight. They have a curve to them, like a significant curve. My friend's curve inwards, okay, like a lot. Like if you grab my finger and just really cranked it. Anyway, he passed that on to his kids. Now his kids have that same thing. You could be like the six-fingered man, and then pass that on to your kids. There's some things that pass on and some things that don't, but propensity for bad things, sadly, passes down. Cancer. Why do you think the doctor asks Pete? Well, maybe they don't even ask you guys because you're so young, but they'll ask you as you get older. So, do you have any cancer in your family? Because if it's your mom or dad have it, you might get it. It's not a guarantee, just there's a chance because it does follow family lines like that. Okay, so this f plus g is a combination of this and this. And so logically, if this child came from these two parents, its two domains are going to follow through and affect the new child function's domain. So what is f of x plus g of x? Well, here's f of x. Here's g of x. I just have to put them in parentheses and add them together. So here's f of x, 2x plus 3. Here's g of x, put a parenthesis and add. G of x is square root of x plus 3. And that's it. There's my answer. That's f of x plus g of x. But what's its domain? The domain is the one domain and the other domain intersected. It's domain of f intersected with domain of g. I'm going to give that to you in number lines because I think it looks a lot cooler when I make a number line for it. Here's the domain of f, and that was right here. X is greater than 1. Here's a 1. X is greater than 1's like this. I'm going to bring that up a little higher. Now, domain of g. The other parent's restrictions. X has got to be bigger than or equal to negative 3. Here's negative 3. And it could be negative 3, or it could be bigger than that. Now, where do you think the child function will work? Yes, sir. Yep. Because this is where they both work. And where they both work, that's where the child will work, where they overlap. Remember how intersect means like overlap? The intersection of Highway 7 and Highway 101 is where they overlap. That's the intersection. All right. That is half the battle. Now, there's a little bit more to know. When you add them, you get this domain. If I was doing a subtract problem, all I'd have to do different is I'd make that a minus, I'd make that a minus, and then I always have the exact same domain. It's still the two parents overlapped with each other. If I change this to multiply, that's a big dot, that's a big dot, and I have the same exact domain. So add, subtract, and multiply are all the same. So which one is different? Divide. To do divide, it goes like this. F divided by g, this is f, this is divided by g, and granted you sometimes see that in a big fraction. They'll write like 2x plus 3 over square root of x plus 3, like that. That's the same exact thing as this though. So really nothing's changed yet. So why is there any difference? In divide, this part, this function, cannot be what now? 0. But wait, I said before that square roots can be 0. Normally, g of x can be 0. We can allow this to be 0. By putting in a -3, for instance, it does not crash this. Why can't I let it be 0 now? Because I'm dividing by it. Do you get how if this becomes 0 now, it's a different thing? Now if it comes 0, now it's going to crash the combined function. So we need to add a third number line here and say, there's one more thing to think about. Can't just look at the two parent domains. We have to say, also, the bottom function, which in this case, the function, is down here. It's that one. It's the second function that's mentioned. The bottom one, g, cannot be 0. Notice I don't care if it even crashes g, because I already handled that part right here. I already know what crashes g, and I've already taken care of that. It's what makes g 0. So let's look at the g function. It's right here. What makes it 0? Come on, say it. What makes the g function 0? It's not hard. -3. So we can't let it be -3. So this new restriction is it can't be -3. It can be anything else from the perspective of not equaling 0 on the bottom. All right, so now where do they all overlap? Still in the same exact spot as they did before. But I will tell you, usually that extra domain, this extra number line, causes your answer to be different. But now, in this case, the only place where all three number lines overlap and everything works is from 1 to infinity. So I could write it as 1 to infinity. Does 1 work? No, because of this top one, 1 does not work. There we go. All right, what you just learned was kind of complicated. I'm going to give you one second example of it. Say f of x, make a nice new problem for this. G of x, f of x is x squared plus 1, where x needs to stay less than 0. And g of x is going to be square root of x minus 3, actually plus 8. Not to be different than last time. Now, I want you to figure out for me. I'm going to give you a simple one to start with. What's f of x plus g of x, and what is its domain? Which is where those two number lines overlap. Pause for a second while I give that one a shot. So let's see if you're pulling your weight around here. First thing is you just have to add them. So what is f of x? I'm going to drop it in parentheses, notice. X squared plus 1. And then the g of x, it gets added in parentheses, square root of x plus 8. Now again, I get when you're just adding things, these parentheses really don't even help you. It's only when you're subtracting things that it really matters. But I'm telling you, get used to this system and it'll serve you well. So now I can simplify this down, and usually you have your lead coefficient first, which is x squared, plus, and then I'm going to put the square root of x plus 8 next, and then I'm going to put a plus 1 at the end. Is that crucial? No, it's not crucial, but you should know that things that have the highest degree are first. This has got kind of a medium-sized degree. It's x to the, its degree is to the 1/2 power, because square roots are the same as 1/2 power. This is the power of 2, and this has a power of x to the 0, I guess you'd say, on it. All right, so anyway, there's your added function. I know some of you probably didn't rearrange it. Did anybody rearrange it? Okay, fine. So anyway, there's your answer. How many of you had it, but it wasn't rearranged? Okay, good. Then the domain is just the two parent ones. Domain of f, which was artificially restricted right here. Here's 0. Had to stay less than that. And then domain of G, which is x plus 8 needs to be greater than or equal to 0, x greater than or equal to negative 8. Here's negative 8. Empty spot there does work at negative 8 and bigger than that. And now where do they overlap? Right in there. Did you have from negative 8 to 0? Did it have a bracket on the negative 8? Good, because it needed a bracket. Does that make sense? Okay, now that's where those two overlapped. Why wasn't there a third number line? What's that for? You're dividing. So let's say I change it to divide. Let's not even rewrite what the function would be. All you'd have to do is do it like this. Write them together, put a divide sign between them. Or you could make a fraction bar and put the square root of x plus 8 here. Okay, so there it is. I did it for you. But now let's add that third number line. For this divided by this, you still need these two number lines, but you need a third number line. Try to figure out what that third number line would be in this case. Third number line is because you're dividing. Do you get that I can't allow this thing to be 0? Back when it was up here, it was okay if it was 0. See, it says or equal to 0. But now we can't let it be 0. So what would make the denominator 0 if x was negative 8? So I got to go down here and put a negative 8 with an empty spot. And it can't be negative 8 anymore. Remember, all this is checking for is that G cannot be 0. The bottom one, the part that's being divided. Again, this is a divide problem now. Okay, so it can be anything else. The only thing that turns it into 0 is if it was negative 8. Now, do you see how it changed? Just slightly, but it changed my combined domain. Now it only works up to 8, but not including 8. So now it's from negative 8 to 0, where it can't be negative 8 and it can't be 0. Yes, sir. It has to be, all three of them have to work, and one of them doesn't in this case. Are you talking about the 8? Is that what's bothering you, is the 8? Do you get that this bottom one just made it so that I can't be negative 8? Yeah. Do you understand why I can't be negative 8? Yeah. Okay. Good. Why would there be a third number? This third number line is only adding in an extra restriction that in all the other problems, we didn't ever have a divide by a function thing going on. So on this problem alone, we have to worry about the second function turning into 0. On those other ones where it was adding the function or subtracting the function, I didn't care if the function was 0. But when I'm dividing two functions, you can't let the bottom one or the second one be 0. Otherwise, the whole thing will crash. That's this extra restriction that x can't be negative 8. So in our old domain, it could be negative 8. Now it can't be negative 8 because of this whole dividing thing. All right, enough said on that. Now let's go to this. This has to do with slope. And it looks really scary, and frankly, I puzzled over it for a few minutes before I understood what was going on. But let me just tell you quick. Do you remember slope? Let's say this is 2, 5, and let's say this point is 8, 10. Do you remember how to find slope? What do you do? So you go, actually figure out the slope on this. Subtract the y's on top, subtract the x's on the bottom, figure out my slope. Don't say it out loud, write it down. Did you get a fraction? Okay, the top would be the 10 minus the 5, which would be 5. And then it'd be 8 minus the 2, which would be 6. So 5, 6. So the slope on this thing is 5/6. Well, of course, that's what we might do in regular pre-calc. Actually, that's even higher algebra. That's not regular pre-calc. But what we do in this class is we take the slope of more complicated looking things. Like, do you get this spot right here is the point x comma y, but what's another name for y? X comma f of x. Good. That's just like x comma y, right? What's this guy's location? It's, again, it's an x comma y, but what's the x in that case right here? X plus h, comma, what's the y right there? That, right? F of x plus h. Okay, so really it's just 2 points again. So this thing right here is really this minus this, f of x plus h minus f of x. See? F of x plus h minus f of x. Over the x is subtracted, which is x plus h minus x. Why doesn't it say x plus h minus x? Because the x and the minus x cancel each other out. Do you get this is just a big slope problem? That's all it is, a big slope problem. It looks really scary, but it's all it is slope. All right, so that formula, if you're not able to comprehend that, you know what? It's honestly okay. I just wanted to show you where this formula comes from. You're going to need to understand that when you hit calculus. That's called a derivative. All right, so back to, we're going to use this big, scary-looking formula. All we have to do then is know, I know what f of x is already. They gave me that. F of x is 3x minus 5. So I'm going to put a 3x minus 5 right there. I'm going to put an h right there. And I need to figure out f of x plus h. Well, if this is f of x, 3 empty spot minus 5, that's f of x. What are they asking me to drop in when they say to do this right here? Drop in what? Come on, say it. Nope. X plus h. All right, I think some of your brains just exploded. 7x plus 4. This is a function. All right, back off to simpler functions. What's f of 2? You're sticking a 2 into the x, aren't you? Okay, and you get 14 plus 4 will be 18. Do you agree that it's 18? Okay, so if this equals 18, do you have the point 2 comma 18 right there then? Okay, good. Now, let's put in x is something a little more complicated. Let's say x is a. What's f of a? 7a plus 4. Okay, not too tough. Just stick in an a, right? What if I want f of a plus 1? Jack, don't sing. If I want f of a plus 1, I just drop in a plus 1. Okay, so does anybody have short-term memory and can tell me that big formula that I had up on the board? F of x plus h minus f of x all over. Very good. So I need to find this first, f of x plus h. So f of x plus h. You drop in 7 empty spot plus 4. That's what variables are. Think of them as empty spots, empty parentheses. Now I'm going to drop in x plus h. There we go. That's f of x plus h. Now I have to subtract f of x. So I'm going to put minus f of x. Remember me saying to put a parenthesis and then drop it in? So now I'm going to drop in f of x. Ooh, that's f of x right there. 7x plus 4. And I'll have it if I just take the whole thing and divide by what? Divide by h. Now, I want you to simplify this right here by distributing it out and simplifying by putting like terms together. And if you do it right, your answer will come out to a nice simple number like 4. Simplify what I have in the box right there. This is not hard. It really isn't. I know it might feel hard right now, but this will be your favorite part of the test. Really. Because it's all relative to each other, right? And even if this isn't super easy, it's easier than the other stuff. All right, so distributing this thing out, I hope. Distributing the negative out, I hope. And then a whole bunch of things canceled, didn't they? Did you get 7x plus 7h plus 4 minus 7x minus 4? Holy cow, the 7x and the negative 7x and the 4 and the negative 4 all canceled out. What's left on top? 7h all over what? And those cancel and the answer is 7. Okay. Now let me show you what your homework is like. It's like that. Arrow down a bit. That's your first problem. And you need to do all of that. There are going to be several we're going to skip on your homework, but this problem, including all of its parts, is part of your homework. I am going to cut it down to be reasonably sized, so pay attention here. So I want to warn you, the domain on this is actually too easy. Because some kids get confused, like, you didn't tell me the domain. What's the domain of x squared? All reals. Yep. I'm going to put a big R for that, and I'm okay with you doing that too. What's the domain of this? Is there any way to crash it? No, there's no square roots to crash, and there's no denominators to crash, so there's no way to crash it. So it's all reals. So when you take a number line that's all reals, and you overlap it with another number line that's all reals, what's the answer? All reals. Okay, so that's going to be a little too easy on the domains. Except when you get to which one? Divide, because that's got 3 number lines. What's the third number line? The bottom function can't be what? So this function can't be 0. So you just have to add in that third number line, and that will actually give you a domain other than just all reals. Okay, so there's your first problem. Then move on to this one. It's a skip. You may skip 16 in its entirety. Then 18 I want you to do, and 19 I want you to skip. And then 21, 23, and 24, those are all good ones, and that's doing this process. First thing you always want to do is figure out f of x plus h, and then all you got to do is subtract f of x, which is this one in the first place, and all divided by h. You follow the little formula right there. So let's figure out f of x plus h on this one. It's 2 empty spot minus 5. What do I drop in again? X plus h. So then it simplifies down to 2x plus 2h minus 5. So that's f of x plus h. Now I got to subtract f of x minus parentheses. Told you those are important, because now when I subtract off 2x minus 5, which is what f of x is, this distributes here and here. And if you don't do that, that's the thing everybody's going to get wrong. And it's all over h. And once again, just like last time, most things cancel out, and you'll end up with a nice, simple, small numerical answer, like 7. Okay, the ones that are called challengers, those are just, if you want to stretch your brain, those are cool challenge problems. All right, this whole page and this whole page are skips. I'm sure you're disappointed, but had I sent you home with those to do, you would have just really gotten confused. I really, really, really try to focus on sending you only home with homework that you actually should be able to do. So I said this is the end of our problems. So you're not doing this orange page, and you're not doing the white page at the very end. Okay? That makes it a very reasonably sized assignment. My deal with you is quid pro quo. I give you something. I give you a reasonable sized assignment. You need to do it. No excuses, because I gave you a very doable assignment. All right. That's all I have for you for today.